Okay, so we already know about finding the velocity and acceleration, so let's just do some applications of this. Oh, and it's really important to know, when an object is thrown up, it reaches its maximum height there where the velocity is 0. It's also important to know when it says a particle is at rest, that means the velocity is 0. Okay, so here we have a position function. An object's being thrown up on the moon. So what time is needed to get to its highest point? So that's where we're going to set the velocity equal to 0. So let's go find the velocity. So negative 27 over 10 times 2t plus 27, set it equal to 0. So I see this cancel, so I've got a negative 27 over a 5, t equaling negative 27, and then multiplying by the reciprocal, I get time 5. So time 5 is that's the time it gets to the highest point. And so this is asking, what is the max height? So that means we're going to put 5 back into the position function. So 25 plus 27 times 5 plus 6. That's a fine answer. I'm just going to leave it like that. Okay, so when we're going to look at velocity, and when it's above the x-axis or positive, that means it's moving up or moving to the right. If the velocity is below the x-axis or negative, then it's moving down or moving left. So let's see if we can figure out some things from this velocity. These are always going to be easy to graph because I'll make them nice to factor. So it looks like that. So you can see that it crosses at 0 and at 1. And it's an upward facing parabola. So when is it moving in the positive direction? Positive direction would be when when the velocity is above the x-axis. And let's just use the t's that are bigger than 0. So t's that are bigger than 0, positive direction would be from 1 to infinity. And then if we're looking for negative direction, that would be below the x-axis, and so that would be between 0 and 1. All right, so I've got this position function, and we're thinking about it like a particle moving back and forth. That's what we do lots of this. We'll have a kind of particle going like this back and forth. So we want to find the position of the particle when the particle is moving at 3 feet per second. Okay, so particle moving at 3 feet per second, that means my velocity is 3, correct? So let's find the velocity. So that's 2t minus 3. So I'm setting 2t minus 3 equal to 3, so I get 2t is 6, and so that gives me t is 3. So that's the time this is happening. And then what do they want? They want the position. So finding the position means we're going to take the s function and plug 3 in. So if I plug 3 in, I get 9 minus 9. Oh my goodness, it's at 0. So it's along the ruler, it's at the position 0. Okay, let's find the time the particle is 10 feet away from the origin. Okay, that's a way of saying that s of t is 10. And I'm going to find that t. So I take my s function, t squared minus 3t, set it equal to 10. And I can see that since I have a quadratic, I've got to get it equal to 0. T minus 5, t plus 2. And equals 0, so that gives me 5 and negative 2. It does say have to be using positive time, so I'll eliminate that. So this is the time, and then it's asking how fast it's moving. So how fast it's moving means we need to put that time 5 into my velocity function, and that's this one, right? So I get 10 minus 3, or 7 feet per second.